Hello everyone, it's Benny, and welcome back to the 3D software rendering tutorial series. Last time, we set up the framework to have a true general purpose transformation system for our software renderer. And in this video, we're going to be finishing that up. We're going to be actually taking matrices and vectors and making our fill triangle function down here actually take all that into account. So, with that, let's go ahead and let's get to it. First off, in the matrix class, we're going to need a new type of matrix that you probably wouldn't need if you were, say, creating a matrix class for OpenGL, for instance. And that is, well, I'm going to copy init identity, and I'm going to create a matrix 4F called init screen space transform. So what this is going to do is this is going to take our vertex position from normalized coordinates, where -1 on x is the left, 1 is the right of the screen, -1 on y is the bottom of the screen, 1 on y is the top of the screen. You know, normalized coordinates. It's going to take our position from those coordinates and into actual pixel coordinates. So 0 is the left of the screen, and whatever your width is, say 800, is the right of the screen, and so forth and so on. And it's going to take in two parameters. One for half width, and one for half height. And yeah, it's that simple. So the way this works is pretty simple. We're going to scale up on x by half width. We're going to scale up on y by half height. So now our coordinates have gone from, say, -1, 1 on x to half width on x. And then we're going to, on x, we're going to add half width. So now it's from 0 to width, because we've added half width to it. So yeah, it's very, very simple transform. We're going to do the same thing for y. The only tricky part is in screen space coordinates on y, 0 is the top of the screen, not the bottom of the screen. So we're actually going to need to change it to scale by -half height. But other than that, that's all we need to do. So in render context, I'm going to change things around a bit. For v1, I'm going to do, say, I don't know, v1.transform. So yeah, I'm going to be doing the screen space transform after the vertices are passed in, because that's how basically every 3D API works. They might not necessarily be implementing it like this, but usually you're specifying stuff in some normalized coordinate that's resolution independent. So anyways, v1.transform, and we're going to be doing a, well actually first off, let's just make it a matrix so it's easily reusable. I'm going to have matrix 4F screen space transform, new matrix 4F dot init screen space transform with, I believe I have access, do I have access to width in here? Or is that, yeah, it's in here. Okay. Get width over 2, get height over 2. Yeah, I'll put that in a new line because it's got a little bit big, but yeah. So, say transform, screen space transform here. I'll do the same thing for all the vertices. And there you go, it's as simple as that. So now everything's in normalized coordinates. There's only one more thing we're missing. And that is, in vertex, we're going to need to do a perspective divide at some point. And the way this works, pretty simple. You take all your vertices and divide them by, well, w. So, do public vertex, I'm going to call it perspective divide, and the way this is going to work, exactly what it says on the tin. We're going to say, well, we're going to return, yeah, new vertex, and it'll be pretty much just impos dot get x over impos.get w, and that same sort of theme for every single one of them. So y divided by w, z divided by w, and you could do w divided by w here. I'm actually going to cheat a bit here. You should technically do it w divided by w, but I'm going to cheat and I'm just going to have w, because we're going to need to keep that around for a future part of the software renderer, and that's just a nice way to sort of cheat and do it. There's no official reason why w has to be also divided by w, as far as I'm aware. It's just something most 3D APIs do. So, but in this case, I am going to sort of break from that convention, and I am just going to store w. I'm going to leave w alone, I should say. Now, something I forgot to mention is why we're dividing by w here and not by z like we did in the 3D star field. And the reason is we're actually going to have two z values for our vertex. One z value, the one stored in the w component, is going to be used for perspective divide. That's the z value we divide by when we adjust for perspective. And the other z value, the one stored in the z component, is going to be the one we use in, well, for occlusion, to determine this vertex is in front of this vertex, and this vertex is behind this vertex, and so forth and so on. And I'll talk more about the two z values and why we bother separating them when we talk about occlusion and how to handle that. But, in short, there are occasions where the z value for occlusion and the z value for perspective will be different. Most of the time, they're the same, but there are occasions where they will be different. So that's why it's important now to make the distinction. The w is the perspective z value, and the z is the occlusion z value. It's important to make that distinction now so that, well, we don't have to do a whole bunch of code refactoring and make life harder on us later. So just wanted to clear that up. So anyways, and now here's where things can be really tricky. Oh, wrong class. In render context, you want to do this before the transform to screen space. So v1.perspective divide, then do the transform. Otherwise, they're doing the divide on the coordinates after they're in screen space, and that can look not like what you'd expect. So yeah. So that should build and run, but of course our coordinates are wrong now, so let's go change a few things. And I'll say, sure, min y vertex. Well, not really min y, max y vertices anymore, are they? So yeah, I'm just gonna throw around usual nonsense. There we go. That should give us something, I think. Yeah, that should definitely give us something. Because I forgot that she needed new vector for f with all this. Okay. And now, it should build. And we crash. Did I put in weird parameters or something? 0 here. No, I want 1, because we're dividing by z. Yeah. And we still crash. Okay, then I must have missed something. So, one moment. Okay, and yeah, I was missing something. You see, we were still using stars.update and render, and not clearing the target and filling the triangle. So, yeah, that's why it was crashing. So I went ahead and commented that out in stars. I went ahead, commented out, where is it? Yeah, all the stuff creating a triangle, so we don't have to worry about that. And yeah, all gone. Also, I discovered something rather unfortunate, I must admit, because despite my best efforts, I still went ahead and got the order of transform, with the screen space transform, and perspective divide backwards. Good job, me. So yeah, you do want to do perspective divide second. And it's really just a basic algebra issue. If you do a divided by b, then multiply that by c plus d, that's different than doing A times C plus D divided by B. It's an algebra issue. So yeah, make sure perspective divide comes second. And then everything will work out. Now, while I was doing things off screen, I decided that, like with the stars thing, I'll go ahead and set up an example off screen so that you can see it, something working, and play around with it. And because I don't want to waste a ton of video time on example code. So, yeah, I'm creating a perspective projection here. Oh. Also with vertex, I decided to go ahead and add the z parameter. I'm just passing in 0. So it really doesn't matter right now. I just decided to go ahead and do that because I'm going to need it for later. So yeah, vertex, just to be clear, has a z parameter. Not really using it for anything, but it's there. Anyways, so I went ahead and set up a perspective projection with 70-degree field of view and some near and far plane values. I have set up a translation, so it's 3 units away from the camera. Has rotation, has some counter that I'm using that as an angle to rotate by. Constructing a transform matrix from the projection times the translation times the rotation. And for all the vertices, transforming it by the transform and using that. And if I build and run, you see... Whoops. And run. You see a triangle rotating around in perspective. And that, if you ask me, is awesome. We have general transformation in place. We can easily use matrices to make things fly around the screen and move our vertices around. And also, we have the ability to, well, get perspective without going through the whole giant manual perspective divide like we were doing with the stars 3D. So now perspective divide is automatic, which is also quite nice. So this is about as interesting as things are going to get with solid-filled triangles. But what about triangles with more complicated things, like, say, I don't know, maybe a texture drawn on it? How would we do something like that? Would it be simple, straightforward? Or would we need to resort to a little bit of conventional wisdom first? Find out next time on the 3D software rendering tutorial series. Hope you enjoyed, hope you learned, and I'll see you next time.